Okay, we're going to carry on with section 3.1. So let's consider the same car. It's traveling at initial velocity, and then at a later point, at a later time, has a different final velocity. Okay, as you can see, these are vectors. Velocity initial is a vector given by this arrow and also the length of the arrow. And here we have again an arrow and a different length. So it essentially just typifies velocity vectors with the arrows. So if we consider that this initial velocity has a shorter arrow than the final velocity, then if we take this initial velocity and we add some delta v, we will then get this final velocity. So we take the initial velocity, remember it's a vector, it's got a certain length, and we want to obtain this final velocity. What do we need to do? Well, this initial velocity plus some vector, which is delta v, should give us then final velocity. So basically what we're saying here is that delta v is vi minus vf. Okay, so this delta v is going to equal this v. I made a mistake here. I hope you picked that up. I'm glad you picked that guy up. Delta v is v final minus v initial. All right. So now what you notice here, guys, is that there was quite a bit of waffling there that I just carried on with. But what you noticed is that the delta v, if v final is